Good morning, everyone. Thank you for joining this webinar this morning on the topic of how to enhance safety and productivity in industrial control panels. This webinar is going to be about 45 minutes long, and then we'll take the questions as we complete the webinar. And please feel free to type in the questions as you go through the webinar, and I will try to answer them at the end as the time permits. So this is primarily going to be on the industrial control panels, and I've done this webinar I think a year ago or so, and I'm just redoing this because there was a lot of interest in this specific topic, and we made some minor changes to the content as well. So, just for introduction's sake, my name is Bhanu Srilla, and I've been at Grace for about 6.5 years now, and I work as Director of Technical Marketing here, and my responsibility is new product definition, strategy, and then also work with the UL 508A standards, and also work with UL 61010 standards and 1436 as well. I sit in the technical committee meetings too. So that's kind of my background. I work with a lot of technical application side of things when it comes to Grace products application, like the permanent electrical safety devices or the Grace ports when it comes to the real application scenarios and such. So that's kind of what my role is currently, and it's more like technical role, what I'm currently doing here at Grace. So let's go to the next slide here. It goes. So hope you guys can hear me, and also you can see the screen, I'm assuming. So the topic outline is why industrial control panels. When I say ICPs, it's a abbreviated form of industrial control panels. Why ICPs pose higher risk? So there are different types of panels that exist, like electrical control panels, or your motor control centers, or your medium voltage switchgears, or distribution equipment, and several things that exist in the electrical space. But the topic here I'm going to focus today is specifically on the industrial control panels, and we're going to talk why it poses a higher risk, and we'll talk about the worker qualification with the tasks associated with ICPs. Because unlike the regular electrical panels, electrical only, meaning where you have a defined qualified electrical worker working on those panels, industrial control panels will have the maintenance technicians or the controls engineers or the PLC programmers, the wide array of people who work on this system. So we'll focus on the qualification of worker and why it is important when it comes to industrial control panels. And then we'll also touch on the disconnect switches, the control panels itself, and different types of the task flows, or the different types of works that's being performed in those type of panels, and what are some of the key design elements when we use the ICPs and engineering controls, right? So when you talk about this industrial control panels, the Grace manufactures products like the programming interfaces, panel interface connectors, PESDs, which is a permanent electrical safety devices for verifying the voltage presence and voltage absence, and we'll just see why those are relevant as you're trying to apply these products in the industrial control panels and systems. And last two things are basically what are some of the considerations, right? So when you take the industrial control panels, what are some of the considerations that as a system integrator or the end user you should be looking at to make these panels safer so that you don't expose your personnel towards this electrical hazards, okay? And lastly, I'll take the Q&A. Again, as I'm going through the presentation, if you have any questions, please feel to type those in, and I'll try to answer them at the end. And then lastly, we'll take the Q&A. Also, I have few handouts that you can see it on your webinar dashboard console, so you can download those documents. Some of those are white papers, and some of those are, again, the data sheets of the products that we sell here at Grace, okay? So a quick overview on the injuries, right? So when you talk about any type of electrical panel or a control systems panel, why it is more important? Because the data what I'm showing on the screen now is from the Department of Labor, Bureau of Labor Statistics, where you can look at the non-fatal injuries, right? Because of exposure to the electricity, there are about 56,390 injuries in the period of 2011 to 2017, which is a significant number. And even if you look at that average is about to 8,056 injuries. So the reason I'm being very specific about this is it's not just the fatal injuries, it's a non-fatal injuries that causes the reduction of the workforce because they can't work on the job, they need to take the time off, and also there's a lot of compensations and claims that goes with that. So there are about 8,056 injuries as the happen every year within that data set from 2011 to 2017. So the next one is fatalities by worker occupation, right? So industrial control panels, as you look at, these things are in the industrial environments. As you look at the installation, maintenance, and repair, as I'm looking at the screen here, those are the occupations that has the higher exposure for the fatalities as well, right? So if you look at this one, there's about a 414 in the 2017 itself. So there's about 354 to 414, and there's an increase in that, right? And the electricians, if you look at 74. I mean, the point I would like to highlight here is, so even though the electricians' injuries are, I mean, the fatalities are lesser, right? But I mean, not good, but still it is fewer compared to the installation, maintenance, repair, because installation, maintenance, repair has more to do with the lockout, tagout, people getting injured because of release of hazardous energy and all other things, because that's one of the areas where we specifically focus at Grace to mitigate those risks with our products, okay? So electrocutions and shock injury data, there's a 67% increase in 2016 to 17. Again, this was the published data from DOL. I haven't looked through anything that's recent in this area. And if you look at this bullet, 90% of these injuries sources machinery. So the point I'm trying to highlight here is the machinery pose a higher risk, as again, what I mentioned before, because it includes different skill sets, different types of people, electricians, qualified people, unqualified people, and people who are performing any kind of a maintenance tasks around those, or even people who are cleaning the equipment and such, clearing the jams. I mean, there's a wide array of things that comes into play. Okay, there's electric burn injury data where I'm showing like a 40% of the workers in installation, maintenance, repair, and 51% in the construction and extraction. So, I mean, for our topic today, we're going to just focus on installation, maintenance, and repair contractors, right? So additionally, the impact of work injuries is also big on the economy. So with the unavailability of the workforce to perform the skilled tasks, again, the cost of injuries was about $161 billion in 2017 alone, and cost for medically consulted injuries is $39,000, and the direct cost of the fatality is $1.15 million. I'm talking about the direct cost only, and if you put the indirect cost, it will probably sum to $3 or $4 million roughly. So preventable injuries that represent either income is not received or expenses incurred as a result of the fatalities and non-fatal preventable injuries. And the estimated time lost is about 70 million days alone in 2017. So this is kind of all the data that's available. This is from the National Safety Council, as I put on the slide source here, okay? So we talked about the different types of the injuries and what causes those injuries, right? So why some of those injuries are caused at the industrial work environment. So one is, the first point I'm highlighting here is the unqualified and underqualified persons performing the task. Okay, what do you mean by unqualified, underqualified? The simplest example could be anyone who is holding a screwdriver thinks he's an electrician, we can open the cabinet, right? Or people who are there to update a program or interface with the PLC, they think that they're only accessing that specific component, so they don't need to expose themselves to any high voltage components inside the cabinet, and they open the cabinet and then try to interfere. And it's called inadvertent contact, right? Because their intent is not really to touch those, but they are exposed still, and which makes it. And they think that I can get away with this, I can just go and safely do this work, but once you open the panel, you're almost in the harm's way, right? And then the production pressure from the management, because most of us know that there's always a production pressure, because when a machine is shut down or there is a breakdown of machinery, there's automatically a lot of pressure from the management, from the production crews, to ensure that they need to bring this equipment up and running at the fastest or the minimum time possible. So that's one of the areas where we see why these incidents happen, is because people try to take the shortcuts, and that also happens primarily if you don't have engineering by design controls or the engineering controls, right? And then the complacency, and we come across people that who say, I've been doing this for the last 20 years, 30 years, and I never had an incident happen, so I know what I'm doing. So that's when people get complacent, they take things for granted, and then they get exposed to this incident, right? And the work culture. So work culture is how far your management is supporting the safety aspect. I mean, I'm sure that many organizations or many end users always say that safety is of the top priority, but I'm sure that when it comes to time pressures and getting stuff done, definitely I think that takes a priority as well. So are you allowing your workers to perform these tasks because of the loss in production or the downtime, or how you're trying to set these expectations of your employees, right? So you can't expect your employees to perform an unsafe work because of the production pressure or loss in your production dollars. So, I mean, this how the management supports your safety as well. That's one of the reasons why I mentioned the safety has to be the top down, not the bottoms up thing. Okay. And then what is an ICP? Let's look at, I mean, I talked about the ICPs, industrial control panels. I also talked about typical motor control centers or a medium voltage switchgear or a power distribution board. So what is an ICP? This is a definition of the ICP from UL 508A. It's basically a power circuit components only, such as the motor controllers, overload relays, fuse disconnects, and circuit breakers, right? And there's a control circuit components only. Those are like a push buttons. So what I'm showing here is a combination of power and control circuit components. That's exactly the problem when it comes to the ICP. As I mentioned, this will create additional or higher risk, right? And the third one is a combination of power and control circuit components. So these components with associated wiring, terminals are mounted on or contained within an enclosure or mounted on a subpanel. So this is what the definition of industrial control panels. The point I would like to emphasize really here is this brings higher risk because of two reasons. One is it involves multiple voltages. This panel could have a 480 volts or 600 volts and 12 volts, 24 volts, or a 120 volts, right? So, and also this will attract people from a different types of skill sets, from a PLC programmer or a control technician or a qualified electrician or a maintenance worker too. I mean, this is something that I come across and I find it very interesting, like the many real-time examples where you see people keep the cabinets open to just do some changes or make tweaks to the control parameters. I mean, we come across this, and I was recently at one facility, I don't want to name it, but their panel was open. The panel was kept open, the door was not shut, but the machine was operating, and I mean, that's not by intent, but that's what is the practicality of it. This is all, we all can relate to that, I guess, okay? So that's why it poses higher risk, because anybody can access the systems and thinking that they're only going to access that specific side of things, okay? So combination of power and control circuit components is one of the reasons why it poses higher risk. The various types of workers involved, as I mentioned, and the skill set of workers, right? A person who thinks that is capable of working on a low voltage system may not be qualified to perform the work on a high voltage system, but he or she may think that they're capable or they know how to do it, and that's one of the reasons. And the production pressures, plant throughput, and the last one, as I mentioned, inadvertent contact with energized parts. So this is primarily because people think that I'm only going to touch this power supply here or this PLC here. I'm not nothing to do with this components, but accidentally they might get in contact with that. Okay. So these are the different classifications. I'm just showing all this Allen Bradley and each and different components here, like the medium voltage switchgear, MCCs, and the MV power, just to give a quick overview of this, because these panels very clearly defines if somebody is performing a task inside that panel must be a qualified electrical worker. Whereas ICPs, there is no clear definition because it includes several voltages too. Okay. So importance of worker qualification ICPs. So qualified person and qualified person, here is a quick definition. This was taken out from NFPA 70E standards. One who has demonstrated skills and knowledge related to the construction, installation, and operation, right? So this is kind of qualified person definition by NFPA 70E. And then unqualified person, there are two types of unqualified persons. This is what I came up with, because first is unqualified electrician who doesn't know the equipment or has not received the safety training. A person working on a medium voltage system is not same as a person working on a high voltage system, so he may not be, he or she may not be qualified for performing that task, right? And then a mechanic who is performing change to fan assembly or change to the coupling of a motor, he or she may not be trained to perform the task inside that disconnect switch or inside that control panel too. They need to call for a qualified person. That's the reason I want to emphasize the difference between these two, so that people don't think that they're qualified for that specific task if they're not properly trained to do that. Okay. So then there's a whole bunch of standards. What I'm showing here is 508A and NFPA 79. So 508A defines the standards for safety for industrial control panels, which is like about a 400 pages or 350 pages booklet. And then 79 is the electrical standard for industrial machinery. Okay, and then there is the installation standards, which on the bottom side here, that talks about NEC code or NFPA 70, which is how do you install those equipments in facilities. And then 70E is basically electrical safety in workplace and how you keep your workers safe, right? So there's kind of 4 different things, but the top 2 things are primarily important because most of the industrial control panels, as they're built or sold in the United States, requires this UL 508A certification and label, and they're currently in their 3rd edition that was released in 2018. They updated a lot of information on the short circuit current ratings. They updated information on several areas on the conductor sizing, protection, and such, right? And then the 79 is the electrical standard for industrial machinery by National Fire Protection Association. Okay. In Canada, they use the CSSC 22.2 number 14, and the Europe EN 60204, and for the low voltage switchgear and control gear in the 61439. Okay. So this is the application of the codes and standards, right? So as I look at this one I'm taking it from the Siemens website, I guess. So if you look at this industrial floor example, the 508A are just the panels, right? Industrial control panels has to be listed and labeled to 508A, and then 79 is everything that goes within that area, right? And then that's a shaded area I'm showing. That's the industrial machinery standards, right? It's not just the panel, it's the entire machinery along with the panel. And then this white area, what I'm showing here is NEC, where you need to follow the installation procedures for how this equipment are connected, how you run the conduits, how you put the disconnects and everything, what the spacing requirements and around those installation practices. That changes again by state, and whichever the edition of NEC they're adhering to. Okay, so engineering control and ICPs, right? So we talked about the several different types of panels. We talked about the industrial control panels. We talked about why the industrial control panels pose a higher risk because of the different types of voltages involved, right? So how do we mitigate some of those risks, industrial control panels? So what I'm showing here is a quick example of a sequester disconnect, right? So as I told you, if you have the sequester disconnect built for your panel where you isolate your power components from your control components, automatically you don't expose your person who is doing the control set of things, working on a PLC or working on a timer, working on a low voltage system, right? So or HMI. So even if they open the panel, they don't get exposed because the power is completely segregated away, sequestered outside this, and completely, that's one of the engineering controls. Most panels nowadays, they come with a sequester disconnect, and if you're designing something, look for the sequester disconnect boxes so that you can install it, right? The other way is, if you don't have the sequester disconnect, right? Some of, if you think about your legacy systems where you have the old panels in which you're trying to mitigate this risk. I'm showing here one of the products. What Grace does here is the Grace ports or the panel interface connectors. The main advantage is you can configure this port in any configuration you want, and you can exactly take out your frequently accessed components outside the door. And once this door is shut, you can still access those components. A simple example could be a PLC programmer or a control technician can access his laptop and update the program to the PLC by using this panel interface connectors from outside the door. So what you're basically doing is he or she is not going to open the cabinet to access that programming port. He will be doing so from outside the door so that he's not exposed to the harm's way, okay? And mechanical electrical interlocks. So one of those things, the interlocks will greatly help is basically before you open the disconnect or before you open the panel, you need to make sure that it is shut down so that that's interlocked, and then without which you can't open the door. So that's why these all the engineering controls are safety by design methods that you can incorporate in your panels to mitigate that risk of exposure and keep your people out from the harm's way, okay? So performing a programming update to the PLC. So this is one of the examples what I'm showing here. So I kind of put this into two different columns. One is an open panel and a closed panel or a through door access, what I'm showing here. So worker qualification, if someone has to open the cabinet, they need to either get a qualified person to verify the de-energized state before you can have the control person go and perform the task, or he or she need to have this qualified electrical worker by the side. So once they de-energize the task, verify the safe electrical work condition, the other person can go and perform the task, right? So the task risks here are electrical shock and arc flash hazard, right? So and then if you use a closed panel or a through door access, now using a programming interface or any other means, you don't need to open the cabinet, so you can perform the same thing outside. There is no risk involved. So that's how you basically mitigate the risk, by not having this person open the cabinet, right? So worker classification, if you're the opening panel, it could be energized work, and then in the normal operation, you can do it in the closed panel, and it's considered inherently safe, right? So these references are from the 2018. I didn't update this, so please do apologize. I'll update in the next slides. The PPE requirement, when you're opening it, you need to follow the PPE requirements per NFPA 70E tables, or in this, in a closed door panel, you can apply your facility PPE guidelines for normal operation. The normal operation PPE criteria will change based on different types of tasks and what you're performing at your facility and what your basic guidelines are, okay? And one thing people really don't pay attention is, by having this engineering control, right? You're not only mitigating the safety risk for your people or mitigating the risk of exposure of the hazard to your people, you are also improving your productivity time too, right? So think about waiting for an electrician and being able to open the cabinet after verifying the de-energized state is going to take you about 20-25 minutes, and then there's a wait time involved, right? And you have like we all come across this. We don't have a lot of electricians waiting around to take on the jobs. It's always on the demand, and by this way, you can just do it in 2 minutes without need for waiting for the people. So from the task productivity standpoint, it's of a huge help as well, okay? So here is a quick work task flow with ICPs, right? So this is something that I came up with using a flow chart, right? So how do you know what you're performing, right? So it's a quick flow chart or a visual to say, okay, I'm performing a programming update to the PLC or configuring a network device, right? So then you question yourself, what components are present in the panel? If it is a power and control circuit components, then it's ICP apparently, and then from here you say is the incoming power is sequestered and isolated. If it is yes, then you can disconnect the switch and you can perform the task. If not, if you have a panel interface connector, if you have an interface connector like Graceport, you can just access those things from outside the cabinet. And then does the panel meet the normal operation? You need to meet the normal operation criteria for 110.4D for NFPA 70E to make sure everything is, all the 6 criteria conditions are met, and then so you can open the panel. If not, you have to down the PPE, use a disconnect, verify the absence of voltage, lock out, tag out, and proceed to work. So this kind of gives you an overview of how you perform the task with ICPs and safely, right? And if there is only components with operating voltage 50 volts or below, you don't need to, right? So ICPs can also have just a single voltage, which is just a low voltage components, 50 or below, you don't need to lock it out per OSHA, and you can just perform the task with the open door, okay? So just gives you a good visual of how you determine what is ICP and what type of risks associated, whether you need to call for a qualified person or whether you can perform the task, and that kind of just a process of how you can go through that step by step to identify what type of worker is required to perform that specific task. Okay, so machine troubleshooting and programming. This is the Grace flagship product. These are the programming interfaces. What I'm showing here is GFCI connectors, GFCI outlets here, Ethernet port, and a circuit breaker. So basically, you can use it for charging your laptop or any kind of a door-mounted accessory power. You can use it, and then you can also access the Ethernet. The other one I'm showing in the bottom is the USB-C and USB-A. If you have any USB-C connection to charge your laptops or charge your phones while you're performing the task, you can use it as well. The one here is a simplex port with the Ethernet connector here. So this is again one more configuration. So these are different types, right? We made about 17,000 different combinations, and they all you will recognize. So one thing that really comes to mind with this is make sure that your products, when you're using a 508A, are either UL listed or UL recognized. So that's going to be a mandatory requirement when you're working with the UL 508A panels, that these are either recognized or listed for UL. Otherwise, you can't use those things. And then reduce PP, right? When you use any of these products, you're trying to mitigate the risk of that exposure. So you reduce the PP requirement because you're performing the task from outside the cabinet. Okay, so we make this in a different combinations. All we need to do is basically let our sales guys know, inside sales team and tech support know that which components you are trying to access in your industrial control panel, and you can configure that specific component, and we're going to ship it out, right? So GFCIs. So we are seeing more and more use of GFCIs in the industrial control panels. So this is one thing that I'd like to emphasize here. Associated equipment and accessory equipment, right? So if it is an accessory equipment which is not part of the normal operation, that is called an accessory. If an equipment that's connected to an additional set of the machinery itself that becomes part of the normal operation, then it's called associated. So if you're using an accessory equipment, meaning if you're using a laptop or if you're using something that you will be only using that equipment for any maintenance functions performed in the cabinet or around that machinery, that becomes an accessory equipment. In that case, UL 508A requires it has to be GFCI protected. So does NFPA 79. Okay. And then receptacles cannot have applied voltage greater than 125 volts. So that's a limitation. And also it can be more than 15 or 20 amps and listed for the applied voltage. So some of the people, I mean, we come across this in facilities that people just plug their vacuums and the maintenance guys will go and do the vacuum around the floor using that. And some people put their heater elements and stuff. Those are not the applications these are defined for. So these are defined for basically 125 volts, and they're limited. And that's the reason, one of the reasons we provide the circuit breaker option as well with our baseboard interfaces is so you can restrict the current draw to less than 3 amps. We can do 3 amps and 5 amps different breakers that will make it useful for your situation. So GFCI requirements with ICP is stringent than NEC 210.8, which is not covered in NEC Article 670. So the one is all the standards are not synced with the same year or the same revision level. So there's always something's behind. NEC is sometimes behind, or UL is sometimes ahead, and UL sometimes needs to catch up with NEC. So these are always happening and very dynamic, right? So I think the 508A is going to insist more and more on a GFCI, so that's a requirement and that's the safer practice, right? And some customers also nowadays looking at, as I showed in the previous slide, they're looking at the USB-C where they can completely eliminate even bringing the 120 volts outside the door so that they don't expose, right? Must meet the environmental rating. So one thing I highlighted in the previous slide is the different types of panel interface connectors that you can get from Grace or any other company. You need to ensure that these housings are matching the UL type requirements, like it's a 4 or 4X or 3R, whichever it is, your panel is designed to. You need to ensure that you meet those requirements with these accessories as well. So, and the next one is voltage verification, right? So this is again a Grace product lines. What we really take pride in electrical safety as we do this in industrial facilities is the voltage presence and voltage absence. So one of the areas you can also mitigate the risk is if you can provide these devices outside the cabinet, so a task qualified person or a qualified person, electrical worker, can verify both the presence and the absence of voltage from outside the cabinet. So we have two different products. One is voltage present indicators, and the one is the absence of voltage safe test point. So basically one is for task qualified persons who are performing the task on the mechanical side of things, meaning if you're performing the task around the coupling or the belt drive, where you're not exposing to electrical conductors, energized parts. So in that case, you can throw the disconnect to off position, and then you can do the OSHA required bump test, and you can perform the task, right? So for which the visual indicators are very handy because it gives you the visual indication of whether the voltage is present, which line is off or on, like even if the stuck blade condition exists on your disconnect, it shows you there with the indicators flashing. and these indicators go up to low as 30 volts, as I'm showing, and some few models go even to 20 volts threshold. As long as the voltage is up at 20 volts, still it'll give that visual verification. So, I mean, what is the main advantage of that? Is basically it gives you that alerting technique, alerting so that you know that there is something that's dangerous, you're not supposed to work on it. So you call for a qualified person to verify what is wrong before you go and perform it, right? So that's one of the reasons why we have the mechanical lockout tagout. It's only for visual voltage presence indication. On the right side of things here, it's electrical lockout tagout, where you have safe test points. This is for high impedance protected test points, where you can put your adequately rated portable test instrument and then verify the voltage absence from outside the door. Okay, so these devices limit the current at the door, and these are listed and labeled to UL 61010, so you can verify the voltage from voltage absence from outside the door. And here is our combo unit, we call it. It's a voltage test station where you can have both the visual verification and also you can do a metered test. So all these devices are UL 61010 listed, and then they're rated for the category 3 and 4. So what it does is by installing these devices, you put engineering control within your panel. So a qualified person, if he or she is trying to perform the absence of voltage to get inside, you can do so the same thing from outside the door in the least amount of time, which is like a minute or two. And also you non-qualified worker, like a task qualified worker performing any mechanical side of operations, not opening the cabinet, right? So he or she can throw the disconnect off, visually verify the voltage is not present, and they can perform the task, right? So these things will greatly increase your task productivity, at the same time minimizing the exposure of the hazard to your workers. Okay, so absence of voltage testing. Most of you know that NFPA 70E, as is shown in the standards for electrical safety at workplace, right? So this one defines a process for verifying and establishing an electrically safe work condition. If you are using this product, what I'm showing on the screen, the GRACE voltage test station, you meet two things within that 120.5. One is you can visually verify the release of stored energy using an indicator, what I'm showing here on the screen. And then you have this safe test point where you can perform the dead live test or 3-point test from outside the cabinet. So the three things, what this specifically highlight is use adequately rated test instrument. So adequately rated test instrument, I think I can go on the next slide and explain to you, but it's basically use the meter that's rated for the application or the category of the working voltage, right? And then you have to measure the face-to-face and face-to-ground, and then test instrument any known voltage before and after test. So what I'm showing here on the right side is the fluke proving unit, PRV220. I think that's the model, so where you can have a handy known voltage where you can test your meter after you perform this task, okay? So this is the one I was talking about, the article 110.4. So once you put these devices outside the door, any of these devices, I talked about the indicators, safe test points, voltage test stations, or your programming interfaces, any of those things, right? If you put it outside the cabinet, and if you meet all these criteria, 6 things, what I'm showing on the screen, the equipment is properly installed, it's properly maintained, the equipment is used in accordance with the instructions included in the listing and labeling, and in accordance with the manufacturer's instructions. The equipment doors are closed and secured, and all equipment covers are in place and secured, and there is no evidence of impending failure. If your equipment meets all these 6 steps of the criteria as identified on the screen, then that task is considered as a normal operation. Then the next question is, what do you need to, PPI need to be donning, right? So that question is basically the facility dependent, whatever is defined as the PPE requirement for your facility guidelines as as the minimum required PPE for a normal operation, then you don the PPE to that ratings. Okay. So absence of voltage testing is just like a flow chart. As I mentioned, this is like your presence of voltage indicator lights on, you go in front of the device, you open the disconnect switch or the energy isolating device, and you select the adequately rated meter, you verify the meter to a known source, verify the absence of voltage, and verify the meter to a known source to confirm the meter has not failed while performing the operation. So once you do that, you verify the de-energized state, you're meeting the NFPA 70E, and with the voltage test station, you can safely perform this task from outside the cabinet. And the one thing I would like to emphasize here is the max fault current, right? So as I mentioned, these devices are tested and listed to UL 61010 standards, and this is under the measurement, testing, and signal generating equipment category. And these devices fall under this PICQ guideline requirements for that. And they need to go through this transient voltage test. And before they list these devices for external door mounted, the UL test labs validate this equipment's use for faulted condition by shorting the terminals and crisscrossing and all these things. So it doesn't create an additional hazard, because these devices have a built-in high impedance on each leg, so that will limit the fault current. So you'll still be able to measure the voltage, what is connected inside the cabinet, but your limit is restricted to 2.94 milliamps at 600 volts and 2.35 480 volts. So you don't create a hazard or a short or arcing from outside the cabinet. So I talked about a few slides ago the adequately rated portable test instrument, right? So this is what exactly explains the importance of application category. So if you look at, probably you might be aware of this class, I mean, Cat 3, Cat 2 rated meters. I mean, you can get the meters from probably $100 to $4,000, $5,000 as well, right? So what's the major difference is basically what this application category is. The one you probably find in Home Depot or Lowe's may not be, I mean, the $50 or $10 ones may not be your Cat 3 or Cat 4. So I'm just emphasizing, because most people think, okay, this is a portable test instrument, I can use it. No, it is not. I mean, you can use it, but it's going to hurt you. So you need to make sure that you pick the voltmeter that is rated and suitable for your application criteria. The major difference is, you see there's a Cat 4 and Cat 3. So Cat 3 goes through this for 600 volts, 6,000 volts is the transient voltage applied to it, for which the product has to withstand. And then for 1,000 volts, it is 8,000 volts is the transient pulses. And then for Cat 4, it's 8,000 and 12,000, right? So you can use a Cat 4 in a Cat 3 application, but you can't use the Cat 3 meter in a Cat 4 application. That's the simplest way I can put it, okay? So how do you mitigate the risks in the ICPs, right? So, I mean, I kind of put this on the handout section as you're looking on your webinar console. So there's a paper, I just put it in. So how do you mitigate the risk? Basically, it's a step-by-step process. You need to understand what type of equipment, even before you design the equipment, you need to understand, right? So if you're speccing out industrial control panel, right? So you need to understand the type of equipment, the people who will be in interaction with this equipment once it's installed and commissioned, not just when it's designed, but installed and commissioned, right? And the different types of hazards involved, and the qualification of workers who will be interacting with that equipment, and then the criticality of the equipment and the frequency of the task. Because the frequency of tasks is an important thing, because how often you're going to perform the task is also going to determine your likelihood of getting in the harm's way for you people, right? And then step 2 plan, list all the activities involved, and then list the components or devices that needs to be accessed in energized condition, and list workers involved in the qualification and hazards associated with each task, right? And the execution phase is pretty simple. Bring the accessible components to the door. I mean, you know that I need to access this Ethernet. You know that I'm going to perform this mechanical task, so I need to have this visual indication. Or you need to know that I need to have access to this USB-C communication port or a data access port I need to be accessing inside. And you define those things during the design phase itself, so you can bring those components outside. So that's going to help you in 2 ways. One, it's going to reduce your maintenance task time as you perform this task, and at the same time it's going to completely limit your hazard exposure to your workers, right? And lastly, I mean, train the employees in the safely performing task, right? So this is one thing most people forget, is these safety by design components or the products are only going to be as useful to the extent how your people are trained. So make sure that the people know what the pros and cons of these devices and what they need to look out while using these devices in a safer way, so that they don't take things for granted, or they need to understand where it's connected. For example, you can have an absence of voltage tester, or you can have a safe test point or an indicator at the door, but if it is not clearly marked where it's been connected inside, meaning it's connected to the line side or a load side or where it is, it's of no use. So make sure that Your drawings are updated after you install the devices, clearly identifying which points are connected and what you're trying to lock out. At the same time, to also tell them what they need to look out for, because safety is not like absence of risk. It's minimize the risk to the least levels so that your people can safely perform the task, right? So you need to also tell them what the limitations of these devices are, right? There's nothing such thing as 100% safe product, okay? So design considerations and ICPs. Understand ICPs pose a significantly higher risk because of the different voltages involved. That's what I always tell our users. You need to understand that because of multiple voltages in 13.8 kV, you don't expect people maintenance guy going and touching that, right? So because you always know that there's going to be a high voltage, this is electrical panel, I need a qualified electrical worker. But with this, if you take the adjustable frequency drives, there'll be people who will be just working on the DC side of things or controller of that, they might get exposed. So that's kind of one of the things, it's a gray area, right? And clearly evaluate the worker qualification and tasks they're assigned to do. So before someone opens a panel, they need to understand what their limitations are, whether they're allowed to open the panel or they need to call for help with the qualified electrical worker. And if they can perform the task and what those limitations are, they need to understand that. So perform the risk analysis and implement control measures that are appropriate by evaluating the type of the task, worker qualification, and also equipment condition. Because equipment that's installed 30 years ago might not pose the same, might not be as same risk. The risk might not be the same as the one that's installed a year ago. A 30 years old equipment might have higher failure points or the risk that you will be exposing your people to. So just evaluate those equipment conditions too before you try to put the different types of engineering controls. Always try to implement elimination, substitution engineering controls in the order of hierarchy. As some of you know, there's this risk control hierarchy where they identify elimination, substitution, and engineering controls as the top of the risk control measures that are applied at the source. Because anything down the line, like your alerting techniques or your documentation or your PPE guidelines, they're all intervened by the human error. So anywhere somebody is following the lower level of risk control, they're going to have a higher exposure to the risk. So always try to go at the hierarchical order and try to put the top three elimination, substitution, and engineering controls in your panels. Always use equipment according to the manufacturer instructions. So this is an important thing too, because whenever you use the equipment, right? So whenever you use Grace products, for example, the voltage indicators or the safe test points, right? If you use the practical applications, you always see there'll be an installation instruction that has been approved and reviewed by the test labs that comes along with the product. Always follow the instructions before installing those devices to ensure that you people go through that details of what those installation guidelines says, and also install as per the manufacturer recommended installations. And also just make sure that you follow the local codes and standards as well, right? The last 4 bullets here is ICP support the accurate labels. So the 508A, NFPA 79, and also NFPA 70E standards ensure that the equipment is marked with appropriate warning labels and arc flash hazard information. Provide GFCI receptacles wherever you require that meets the enclosure type rating, because you can't just have a GFCI receptacle just by standalone that doesn't meet the environmental rating of your panel, right? You need to have that, you need to use your type rating that's required for that specific panel to meet that. And keep electrical drawings up to date, because most people don't do a great job with that, because they'll make the updates to the panel, they make the modifications, but ultimately sometimes they'll forget about what has been updated. They're not marked up on their drawings, right? So without which it's, people who are performing the task might not be aware of what's been updated and how the system works. And every time you make those changes, make sure that your drawings are updated and your people also trained. Follow all your equipment and facility lockout tagout procedures, because every facility has their unique lockout tagout procedures and the guidelines on how to perform this task. So make sure that you follow through those, okay? So this is one of the industrial control panels one of our customers shared with us. As you can see it, you can see a voltage indicator, one on the line side, one on the load side. Also, they have the safe test point for verifying the absence of voltage from outside the door. And at the bottom, they also have this Grace port programming interface. This is like a great panel in my view, because it has all the Grace products in it. So I think with that, the summary: exposure to ICPs are higher risk. Frequent interaction increases the hazard probability. Complacency makes workers less attentive while performing the task, and always verify the de-energized state before opening the panel, and use engineering controls to minimize the risk exposure, and use appropriate PPE as per your facility guidelines for the task. And with that, this is my information. If you have any questions, please feel free to reach out to me. And if you have product questions, please reach out to our inside sales team and tech support. They'll be more than happy to assist you. And I will see if there is any questions coming up here. Available in all languages. I'm just looking at the question. So there are a few questions. Is there an English version of the misconceptions, voltage, technical, testing, optical? Yes, there is an English version, and if I updated the Mexican Spanish version, I'm sorry, I will also update the English version as well. Please, I want to be certified by Grace Technologies. What are the procedures? There is no certification by Grace Technologies. We don't certify any. We don't certify people. We certify the products. So I mean, we certify our products through the test labs. How do I implement electrical safety process to my company who are not safety compliance and conscious? I think that's you need to talk to your management or your supervisors to ensure that they understand the risks of electrical tasks and the hazards involved with electrical tasks, and then probably you need to come to a consensus. Is there any risk to arc flash migrating from a 480 volt side through conduits into a control side? Do control techs need AF rated PPE? I don't really understand the question here. Yeah, I mean, if there's a control technician who is performing the task inside the cabinet, if that's a question, and if it's exposed to the 480 volts, absolutely you need to be done the PPE, or you need to also have a qualified electrical worker come and verify the de-energized state and put it logged out before the control technician can go and perform the task. Kindly share with me the slides of presentation. Yes, we will share the presentation slides after the webinar. You'll see a follow-up email after this from Nick, and he will include all the information. For Europe, do you have a CMRP Grace port outlet with European sockets and GFCIs? Yes, this is absolutely correct. Yeah, we have the Grace port that can be configured into UK or European Union outlets, and also a GFCI or RCD as well. We've been lately getting more requests about the residual current device, which is a requirement in the UK and European Unions, and that can be configured within the Grace port as well. Absolutely. Next question. For voltage presence indicators, what is your recommendation for overcurrent protection of the device versus false indication of the false safe condition? That is, say, if fuse is blown. That's a great question. I mean, these are some of the questions I get from the end users and the field inspectors and such, right? So I'm going to tell you this, right? So use of a fuse within the context of UL 508A and the comparable CSA standards, it doesn't require a fuse protection because this device has been tested as a fuse that limits the fault current, okay? And then these are 18 gauge wires too. So second thing to that is, as long as you're not extending this device beyond your terminated connection inside the cabinet, and that stays within that 3 meter length. So our devices go from 6 and 8 feet lengths. So as long as those are like less than that 3 meter, which is like a less than 9.9 feet length, you can use this device without the fuse, with the feeder tap rule. And also, as long as you protect this lead wires using an abrasion resistance wire sleeving, so that these wires don't get mechanically hit the sharp edges or get into the door jams, so you're good to go, right? So only thing is, if you are extending this leads beyond what is of the supplied length, you need to protect it with the fusing. And if you're connecting the device leads in box A and the front of the device goes to box B, you are going from one box to the box, then you require a fusing. So we're updating all our installation manuals to reflect that language. We went through some UL review and all that's been identified, and we'll be updating the information. If you have more questions around it in your specific application scenario, please reach out to me. I can just walk you through the different sections, how this applies and why the fusing is not required. And absolutely correct. And fusing creates additional point of failure because in the safety application, a blown fuse can make an operator feel that there is no voltage present, which is otherwise. Okay, that's one of the reasons where we are very specific about not recommending fuses when use these devices in safety application for both voltage presence and voltage absence. Okay. Are your voltage presence labels available in all languages? I think it's available in few languages. I'm not sure. Probably I will verify with our engineering team and get back to you, Stephen. Hope to receive certificate of attendance from you, sir. Yeah, absolutely. We'll be sending the certificate of attendance. Nick will reach out to you. He's traveling this week, and he'll definitely get back to you maybe next week and get you that information. Thank you, Bhanu. Good presentation. Flavio, what is the safety requirement switchgear safety specialist? I think this question came up last time. The safety requirement for a gas PVC line passing less than a foot from a 2 HVAC motors, 50 HP. I think I remember seeing this question. I think in the last month's webinar presented by Charlie Miller, who is an expert who from NEC side of things, and I will consult and get back to you, John. Absolutely, I will get back to you on that. Okay, because he is the go-to person when it comes to codes on the NEC side of things. I will do that. Okay. I think that's about all the questions I see. Again, thank you so much for joining the presentation, and I hope this is somewhat informational. And if you have any other questions or feedback, please send me a note. My email is on the screen. And also, if you have any questions on the products, please reach out to our Insight technical team, and they'll be happy to assist you with your products and go from there. Thank you so much. You guys have a wonderful rest of your day. Bye-bye.